Right, I want us to look at the sigma notation. Whenever you see this sign, it's a summation sign. It means sum. We are adding together sum. What is this saying to us? We are given this in a sigma notation form. What do we usually have on top here? On top of the sigma notation, it is the number of terms. At face value, I will think that these are 99 terms. What is this? T is equal to 0. This is actually telling me what T. This one, this side, it is generally called the general term, the nth term, or the last term. The general term, the nth term, or the last term. So what usually stays here is the general term. La, sitshela ivalue ka-T ukuthi uT siqala ukubala ku-term yesingaki, laphaya usitshela a number of terms. Let's look at the example 2 that we'll do with you. This one is telling us that terms esiwahlanganisayo in this particular case are 20. Siqala ku-term yesingaki ukubala, siqala ku-term yokuqala. This gives us the general term. Khumbula in the earlier lessons, for us to know what type of a sequence lento esiyihlanganisayo, it can either be the arithmetic sequence or the geometric sequence. Siyibona kanjani arithmetic sequence? In a common difference. Kepha siyibona kanjani geometric sequence? It should have a common ratio where T2 over T1 will be equals to T3 over T4. T3 over T2. Right. Let's look at this one here, the first one. It is important to note that iyasiza ukuthi mawusebenza ikunika the idea ukuthi usebenza nge-arithmetic noma nge-geometric. Look at T here. Look at our unknown in this particular case. This T, uphansi, it's 3T. But when you look at this one, u-n ukephi uyi-exponent. Our unknown in this particular case is an exponent. Whenever unikezwe i-unknown eyi-exponent in that particular case, as ukuthi it will always be a geometric sequence. It will be linear, it will be arithmetic sequence. If that T was on top there, bengazi ukuthi bengizosebenzisa i-formula ka-sum kani geometric. But in this particular case, I should know that it is arithmetic, but if it is an exponent, it will be a geometric. Look at the first question. In the first question, I must write the first 3 terms of the sequence. Why 3? Because 3 is the ones which it's either in a common difference or in a common ratio. 3 is important. Write down the first 3 terms of the sequence. What are the first 3 terms? But do I know the general term in this particular case? Yes, we do have the general term. In this case, this is the general term. The general term for this next one, it is this one. Right. So whenever I'm looking for the first 3 terms, I've got to use the general term. I know that T1 is equals to, this is what I have. T1, in fact, I get to Tn so that it will make sense. Tn will be equals to 3T minus 1. I'm going to N, I'm going to TT, so that it will make sense. If this was N, I was going to say Tn, but I'm giving there as T. Unlike in this particular one, I'm giving it as N. So I will use whatever I'm given here. Here I'm given 3T, so I'm going to use term T. Remember, this is another important fact about this one. Siqala ukubala from term 0. If nginama terms amangaka, 2, 4, 6, 8. Nginama terms amangaka lapha 1, 2, 3, 4. Ngiqala ku-term esingaka uku-adda. If ngithi mina ngineza ama-term 1, 2, 3, 4. Kodwa ngicela ungihlanganisele lama-terms uqale ku-term yesibili. Mangaka ama-terms engizowahlanganisa. Mangithi hlanganisa zonke lezi zinamba la uqale ku-term yesibili. Which is zingaki inamba engizoyihlanganisa zintathu, because I'm starting from the second one, following my instructions. But if mangithi nje hlanganisa lama term, qala ku-term yokuqala, so ngizowahlanganisa wonke abe u4. So I'm starting from the first term. So lento le ingitshela ukuthi ngiqala ku-term yesingaki. This one is telling me ukuthi ngiqala ku-term yesingaki. So whenever I'm adding this, I will be starting from the first term, But when I'm adding this, ngiqala ku-term yesingaki, ngiqala ku-term yes0. Okusho ukuthi angiqala in this particular case. So mangaka ama-terms engizowahlanganisa. Mangiqala kule azoba ulokhu plus 1. So mangaka lawo now njengamanje awu-99. but angiqala ku-term awu-99 mangiqala ku-term yokuqala, but mangiqala ku-term 0 asizobanga ngama-terms engiwahlanganisayo azoba 100. So that becomes a trick there. It is important that we should understand that if we've got ama-terms awu-99, masekuthiwa angiqala kweyokuqala ngizobhala ama-terms awu-99. But this one says angiqala ku-term yes-0, so awasayeno 99 asemangaki ase-100. Unlike in this particular example here, ngiqala ku-term yokuqala ukubala ama-terms amangaki awu-20. Kusho ukuthi mangaki ama-terms engiwahlanganisayo awu-20. But la ama-terms abawu-99 angiqala kweyokuqala ngiqala kwe-0. Okusho ukuthi ama-terms azoba mangaki plus 1 lapha ku-99. So we know n wethu in this particular case, it's not going to be 99, but uzoba ubani 100, which is 99 plus 1. Ngoba siqalanga ku-term 1, siqala ku-term 0. So there's one extra term oyi-adayo lapho. So right, u-TT will be equal to 3t minus 1. But now we know that the first term is not i-term yokuqala, iqala kule term 0. I-term yokuqala yethu izobe ku-term 0. So u-T0, so T0, T0. So when there's T sengifaka ku-0, because the first term izoqala ku-0. So le nto le itshela ukuthi uqala ku-term yesingaki, ngiqala ku-term yes-0. So T0 will be equal to 3 into 0. Where there is T sengifaka ku-0, 3 times 0 minus 1. What is 3 times 0? It is 3. 3 times 0, it is 0. 0 minus 1, it is minus 1. So we know that i-term yethu yokuqala in this particular sequence will be minus 1. The first term will be minus 1. Let's check as part of the first 3 terms. So we do have the first term, which is in this particular case minus 1. I-term yethu yokuqala beku-term 0. Eyesibili senza term 1. So u-term 2 wethu uzoba u-T1, because we're starting from term 0. So i-term yesibili uzoba u-T1, T1. Right. Now look here. This is the machine that we are using, the general term that stays there. Now we're looking for term 1, which is the second term now, because we're starting from term 0. So when we're looking for term 1 in this particular case, it will be 3. Wherever there was T, we're pushing in 1 now. Exactly as you see there, it's going to be 1 minus 1. Whereas 3 times 1, it is 3. 3 minus 1, it is 2. So the second term in this particular case will be 2. Of course, it is the first term, term 0. But because this one says we're starting from term 0, so this becomes our second term. Let's look at the third term. The third term will be the second term. So T2. Where there is T, where there is small t now, there is 2. So do the same thing on that side. So it's going to be 3 into 2 minus 1, which will give us what? 3 times 2, it's 6. 6 minus 1, it is 5. So these are the first 3 terms of this sequence that we are dealing with. We've got the first term as minus 1, 2, and 5. Because this is not at the exponent, so it is here, linear. Therefore, we know that we're going to have an arithmetic sequence. So by arithmetic sequence, but let us check it. Let's look at the terms that we have. The question was, write down the first 3 terms. So this is T1, this is T2, and these are the first 3 terms. We've responded to the question, and we got all the marks. 4.1.2, calculate the sum of the series, the sum. We're looking for the sum, therefore we use formula sum. Iti formula sum, iti Sn is equals to n over 2 into 2a plus into n minus 1d. But how did I know who to sum? Let us check it first, who to sum, before we apply the formula, because it might be geometry. But from experience, you should know that if we tear pant, it will be the arithmetic. Let's check it. What is the first term? It is minus 1. What is the next term? It is 2. What is the next term? It is 5. These are the 3 terms of my series. Let me check if it is indeed the arithmetic. Sibona kanjani arithmetic, if I a common difference. Let us check the difference between these 2. What is 5 minus 2? 5 ususa 2 kwenza 3. What is 2 minus 1? You can write it down so that you can see it. What is 2 minus 1? What do we get there? This will be minus times minus, it will be plus, so it's 2 plus 1, which will give us 3. This has got a common difference of 3. Therefore, it is the arithmetic sequence. So when we're looking for the sum of the arithmetic sequence, we use the formula Sn. This one says calculate the sum of the series. Right, let's get this one clear. It is important that even before I write this, I must know what I have. I must know what I have. All right, this is my sequence. Do I have the value of A there? What is A? Collecting the data makes life easier. What is the value of A there? It is -1. Do I have D? Do I have my common difference? Yes, I do have my common difference. Which is what? Which is 3. What else do I have there? Do I have N? Yes, I do have N. I know how many terms will I be adding. How many terms will I be adding? If I was starting from the first term, I was going to have 99 terms. But we're not starting from the first term. We're starting from the term before that, the 0 term. Therefore, the N will be 100. Remember that the number of terms in this particular case is not 99, but 100. Be careful of this one. This one, it will be much more easier. The number of terms here will be 20 because we're starting to add from the first term. Suppose we're dealing with this one, and here it is not 1, it is 2. So how many terms will we have? Sithi la sinama terms wonke asephelele awu-20, but siqala ukubala from the second term. Ama-terms esiwahlanganisa awasezikuba u-20, asizoba u-19, because sizoqala ukubala from the second term. So this becomes very important. In this particular case, ama-terms abe u-99, but asiqala ukubala from the first terms. The one that is before the first term, awasezikuba u-99 esiwa-adayo, asizoba 100. Hence, we say the number of terms here, it is 100. Right, that's what we have here. So we know that it is an arithmetic. It has a common difference of 3. The first term is -1. And the number of terms that you are adding is no longer 99, it is 100. The formula is Sn is equals to n over 2 into 2a plus into n minus 1d. Right, make sure that you close that bracket off there. How many terms are we adding? The n stands for the number of terms, number of terms, number of terms. U-a umele ini, the first term, u-d umele ini, the common difference. Let's push it in there. Sum of the first 100 terms, this is just not any 100 terms, but the first 100 terms, will be equals to, remember, where there was n, we're pushing in 100. You just do that, nothing else. So instead of n, what do I write? I write 100. This is divided by 2 into 2 into, what is the value of A? You look at your data, you do have your A as -1. You plus, how many terms are we adding? There are 100. What is 100 minus 1? It is 99. What is the value of D? The common difference, it is 3. Close this bracket and the bigger one. So the sum of the first 100 terms will then be equals to, you go to your calculator, it will help you to find the exact solution. Remember, you know what is 100 over 2, which is 50. So we've got 50 there into, open that bracket, what is 2 times minus 1? It is -2, so it's -2 plus, what do I have there? 99 times 3, 99 times 3. Close this bracket, and I also close the bigger one. What is my solution here? This is what I get, 14750. This is the sum of the first 100 terms of this sigma notation form. Remember, we are required to find the sum of the first 99 terms, but we're starting from 0 term, it makes them 100 terms. Hence, I'm looking for the sum of the first 100 terms. Remember, this is your general term, the number of terms. Let's look at the next one. I've picked 2 because this one talks of a geometric. How do I know that it will be geometric? Because n we exponent. If this n was down here, this was going to be an arithmetic sequence or arithmetic progression. Right, let's look at what we have here. Remember this side, you always want to have your general term or your nth term or your Tn. This is my Tn. What is this? It's the number of terms. How many terms are we adding here? We're adding 20 terms. Starting from term yesingaki, we're starting to add from the first term. Unlike the previous problem where we started to add from 0 term, hence we had 100 terms there. If we're starting from the second term again here, if we're starting from the second term, we're going to have 19 terms that will be adding together. Right, we need to evaluate that. In other words, we want to find this, the sum of the first 20 terms in that particular one. Now, let's just check it. Let's find the first 3 terms and check it whether it is an arithmetic or geometric. But from experience, we should know that this will be a GP, a geometric progression. Let's look at the first 3 terms. T1 will be equals to, let me start by writing the general term. This is the general term. Tn is equals to 3 to the power n minus 2. This is the general term. Let us find the first three terms. T1 will be equals to 3 to the power 1 minus 2. 3 to the power 1 minus 2. That is the first term. What is this going to give us? This is going to give us 3 to the power 1 minus 2. It's 3 to the power minus 1, which is the same as 1 over 3. So we do have the value of the first term. Remember, the first term is the same as A. So we do have the value of A in our data now. Now that we've got our term 1 as 1 over 3, let's find out what our term 2 is going to be. Remember, that is T2. This will be equals to, you go to your general term, where there was n, it's 2. So wherever you see n, you've got to push in 2 now. It's going to be 3 to the power 2 minus 2. What is this going to give us? What is 2 minus 2? It is 0. What is any number to the power 0? It is equals to 1. So we do have the first two terms now of this sequence that we have. Let's find the third term. Remember that you need a minimum of 3 terms in order to tell whether it is arithmetic or geometric. But generally, we know that once any exponent is going to be geometric, it will have a common ratio. Let's find the third term. So it's going to be equals to 3. Instead of n, now we have what? Instead of n, we have 3. So it's going to be 3 minus 2. What is this going to give us? What is 3 minus 2? It is 1. What is 3 to the power 1? It is 3. So we've got the first 3 terms. What are our first 3 terms? It is 1 over 3. The next one is 1. The next one is 3. Ah, great. Let's look at what is happening here. We've got 3 terms. To move from this one to that one, si multiply ngobani le ukuze kuphume leya. Le number le si multiply ngo3 ukuze kuphume 1. 3 times 1 over 3. If I multiply this by 3, this 3 will cancel with this 3 and we're left with 1. So this one si multiply ngo3 ukuze kuphume 1. Le landela le si multiply ngoba ukuze kuphume le si multiply ngo3. Na le landela si multiply ngo3 ukuze kuba 9. So the next one would have been 9. So it has a common ratio. This divided by this is what? 3 divided by 1 is 3. 1 divided by 1 over 3, it will be 3. So this one has got a common ratio of 3. So we know the value of R in this case. R is 3. Now when we collect our data, we know that our R is 3. We also know that our first term is 1 over 3. And we know that the number of terms, how many terms that are we supposed to add here? We're supposed to add 20 terms. And we know that our n is also equals to 20. That's all that I need. I need to know my first term, my common ratio, and the number of terms. I'm adding here 20 terms. I'm evaluating the sum of the first 20 terms, starting from the first term, using this general term. This is what we're doing here. We're going to find the actual value of the sum of the first 20 terms, starting from the first term, using that general term. Let's do this thing. So the formula is Sn is equals to. Remember that with geometric progressions, our formula 2. This R is bigger than 1. Therefore, R is over on the left-hand side. So Sn will be A into, you start with R. R to the power n minus 1 over R minus 1. That's our formula. Right. Do we know which is sum to how many terms? Yes, we know. Because we know the value of n. We're looking for the sum of the first 20 terms. So we're looking for S20. So where there's n, we push in 20. Right, we move on to that other side. Do we know the first term? Yes, we know the first term. It is 1 over 3. 1 over 3 into. Do we know the common ratio? Yes, we know. It helps to have your data handy. Yes, we do have our common ratio as 3 to the power 20 as the number of terms. Yes, minus 1. You close this bracket, you divide by, what is R? R is 3, of course, R is 3, minus 1, which will give us 2. What is the actual answer here? So take your calculator, you work it out, you punch exactly what you see. Remember, what is 3 minus 1? It is 2. So that is divided by 2. So the sum of the first 20 terms would be, you press your fraction button. On my numerator, I press 1 over 3. It's another fraction on my numerator. It's 1 divided by 3. You punch this next bracket exactly as you see it. Your calculator work becomes important. into, what do I have there? I've got a 3. This 3, you plus x on a square phezulu lapha, which will be power 20. You bring it down. It's minus 1, minus 1. You close that bracket. You close it. Right, that's what we have. You go to my denominator. In this case, my denominator is 3 minus 1, which will give me 2. Then the final answer will then gonna be, so the sum of the first 20 terms will be 5, 8, 5, 8, 113, 113, 0733, 0733, comma 3. So the sum of the first 20 terms will give you exactly that other value there. So that was the using the sigma notation. Remember, you might get t wako abela, nomu n wako abela, nomu k, whatever variable that you have. If you pants, as good, we are going to be dealing with the sum of the arithmetic sequence. If variable yako lapha, exponent, we are going to be using the sum, yeah, geometric sequence. Thank you.